To another video on the binomial expansion. This is the third video in the series, and I'm your presenter, Aaron Lewis. There we go. Quick topic outline. So in this series of the binomial expansion, we have 5 lessons. In the first lesson was using combinations and factorials. In lesson 2, we're applying the binomial expansion to some basic questions. Lesson 3, which is this one, applying the binomial expansion to some harder questions. Lesson 4 is calculating coefficients and indices, and lesson 5 is applying the binomial expansion. So in this lesson, we're applying the binomial expansion to some harder questions. In the previous lesson, we looked at the binomial expansion, but applied it to some more basic examples. Make sure you've watched that video, and you've got plenty of practicing before attempting this video. So in this lesson, we're going to learn how to apply the binomial theorem to some more difficult questions and some more difficult examples. Again, this will include your calculator to work out combinations and coefficients. This lesson is suitable for A-level students, and the language of this lesson is English, and this is around 30 minutes as the previous 2 were. So the learning aims of today: to be able to calculate a binomial expansion where fractions are included on the inside of the bracket. So in previous examples, we had whole numbers inside the bracket. Today we're going to be using some fraction work. And also to be able to manipulate an algebraic expression and then apply the binomial expansion. So here we go. This lesson assumes you already know how to apply the binomial expansion and you can work the formula out, or know the formula. So here we go. So this time I'm expanding x squared plus a half, all raised to the power of 5. So this is a more difficult example, but I'm not going to change what I did from the previous lesson. Now I don't have the binomial formula written at the top this time, but I think I can remember it. You don't need to, feel free to look it up or write it down now. So the binomial formula says take the first term, which is x squared, and raise it to the power of 5. Underneath is going to be 5 choose 1, x squared to the power of 4. Here comes the half, raised to the power of 1, which is just still a half. The next term, 5 choose 2. I'm going to raise x squared to the power of 3. Then a half is going to be squared. The next term, 5 choose 3. X squared multiplied by a half cubed. 5 choose 4. X squared to the power of 1. 1 half to the power of 4. And the final term is going to be half to the power of 5. So that there is just writing it down. That is so important that that's written down correctly. So what I'm going to do is I'm going to use the calculator to work out any horrible coefficients. In fact, all the coefficients. So first of all, let's look at this first term. You've got x squared raised to the power of 5. So you might know the rule from GCSE, which means x to the a raised to the power of b is x to the ab. Or your teacher might have said to you, if it's in brackets, you just times the powers. So that's going to be x to the power of 10. This next term then, well, first thing I'm going to do is I'm going to work out the coefficient. I'm going to be using my calculator. So here we go. It's going to be 5 choose 1. 5 choose 1, which is 5. And we've got 1, there's a 1 in front of that x squared. So that's why there's 1 raised to the power of 4. I know you don't need to do that. Multiplied by a half. So that gives me 5 over 2. 5 over 2. And the same rule again for the powers, or the indices. X squared raised to the power of 4 is going to be x to the power of 8. So I'm letting the calculator do all the difficult arithmetic. The next one, 5 choose 2. Here it comes. 5 choose 2, which is 10. Multiplied by 1 cubed, because there's an imaginary 1 in front of that x squared. And then a half all squared, and again that gives me 5 over 2. Let's sort the indices out. So I've got x squared cubed, which is x to the power of 6, which multiply the powers. This next term then, 5 choose 3. Here it is. So that's 5 choose 3, which is 10. And then it's going to be 10 multiplied by 1 squared. I mean, you could just write that as 1. Multiplied by a half cubed, which is 5 over 4. Just get rid of my calculator a second. There it is. Just rub that a little bit out there, in case you guys are writing this down. And then all we need to do is multiply those powers, x to the power of 4. And the final term here, you can see what pattern I'm taking. I'm just going to get rid of that naught there. That's not very good, does it? There we go. So 5 to the power of 4. Sorry, 5 to the power of 4. 5 choose 4 multiplied by x squared multiplied by a quarter to the power of 4. So what's going in my calculator? Let's have a look. There it is. So 5 choose 4 is 5. 5 multiplied by, well, there's a 1 in front of that x squared, which is raised to the power of 1. Multiplied by half the power of 4 gives me 5. Just lost my pen a second. There we go. 5 over 16 x to the power of 2. Because if you want to pretend there's a 1 there, 2 times 1 is 1. And then the final term, again, I'm on my calculator, a half to the power of 5 is 1 over 32. I would be tempted to leave this as fractions rather than decimals, because the decimal can get quite long and take up a bit more space than it needs to. So my final answer then, written in descending powers of x this time. And remember, that's because the x is at the front from the previous video. Plus 5 over 2 x to the power of 8. Plus 5 over 2 x to the power of 6. Plus 5 over 4 x to the power of 4. Plus 5/16 of x squared plus 1 over 32. Just managed to squeeze that in there. If you're writing this out with me on resource sheet 1, you should have a fair bit more space than me. And there we go, so that question's done. I've used the calculator to cope with any of the difficult arithmetic, and all I've done is just paid attention to my laws of indices. Here's your example. Pause the video and have a go now. Right, so hopefully you had a go at that example and you notice my sneaky subtraction sign. Watch out for that. But if you write it out properly with brackets like I do, your calculator will absorb the minus sign and deal with it for you. And there we go. So there is the answer for that one. Pause the video, mark it, check it, and I'll see you in the next example. So here we go, next example. A little bit more difficult this time. So just need to be really, really careful. Notice this time we've got the x term, which is the second term or the right-hand term in this case. Let's see how I get on with space for this one. So the first thing I need to do is raise a quarter to the power of 4. Now, before I move forwards, having taught this for a little while, you might be tempted to put a line in between your choose because we're writing a quarter. So if you want to write 0.25, you can do, but I'm going to be using a quarter. I'll show you what I mean now. So the next term is going to be 4 choose 1, which looks like that fraction above, doesn't it? There's no fraction line there, so just be careful. So it's going to be 4 choose 1 multiplied by a quarter to the power of 3 multiplied by 3x cubed, like that. So I'm not changing my tactic from the previous questions. It might be easier actually with your quarter here to use a slanted line like that. So that's going to be squared, and that's going to be minus 3x cubed, also squared. So I'm really, really paying attention now because it's getting quite difficult. 4 choose 3, 1 quarter to the power of 1, minus 3x cubed, all cubed. And the final term then is minus 3x, all to the power of 4. So if you can write that down in your exam, you probably will pick up marks for that. Probably going to run out of space here. So in my calculator for the first term, it's going to be a quarter to the power of 4, which is 1 over 256. There we go. So in my calculator for the next term, this is where I really, really need to focus. It's going to be 4 choose 1 multiplied by a quarter cubed multiplied by minus 3. Remember, this the cubed is only on that x there. It's not outside the bracket, so I won't be cubing the 3. So it's be 4 choose 1, multiplied by a quarter cubed, multiplied by minus 3. Here we go. There it is. So 4 choose 1 is 4, multiplied by a quarter cubed, multiplied by minus 3 to the power of 1. You don't need the 1 in here if you don't want to. So what's that going to come out as? Minus 3 over 16. Minus 3 over 16. And it's going to be an x cubed because that's an x cubed term there. Next term. 4 choose 2, multiplied by a quarter squared, multiplied by minus 3 squared. So just be really, really careful. Here comes the calculator. I'm just going to rub out that little bit of wet there and I'll put it back in a second. Just so you can see the calculator. Okay, let's have a look. So 4 choose 2 is 6, multiplied by 1 quarter squared, multiplied by minus 3 squared. And I've let the calculator do the difficult arithmetic for me. And that comes out as 27 over 8. 27, lost my pen. 27 over 8 x. So it's cubed squared, so it times the powers. X to the power of 6. Next term then. In fact, I'm just going to pull up the other one because I've lost it. Minus 3 over 16. Minus 3 over 16. X cubed. We'll see if I can see the calculator underneath. The next term then is going to be 4 choose 3, multiplied by a quarter, multiplied by minus 3 cubed. Here we go. 4 choose 3 is 4. So that's going to be 4 multiplied by a quarter, multiplied by minus 3 cubed. The calculator's doing all the difficult arithmetic for me. Minus 27 x, and I've lost a cube there. We've multiplied the powers there. I think I've lost a cube there as well. If you spotted that, well done. X to the power of 9, because we just times the powers. And then for the last term then, what's going to go in the calculator? Well, no, it's going to be x to the power of 12, just times the powers. And minus 3 to the power of 4 is 81. So my final answer, after all that, is 1 over 256 minus 3 over 16 x cubed plus 27 over 8 x to the power of 6 minus 27 x to the power of 9 plus 81 x to the power of 12. Now there are some other patterns going on. If you want to spot those, you can do, but it's not a requirement right now. So here's your question. Pause the video and have a go now. Okay, so hopefully you've had a go at that question. Here's the answers for you to check, mark correct. And there we go. If you need to make any improvements, make them now and adjust your working. Okay, what I'd like to do now is have a go at mini quiz 1, have a go at the multiple choice questions and spend some time reflecting on those answers. Okay, so moving on to the next section, here we go. So this time we're going to manipulate some algebra and then apply the binomial theorem. Now these questions are unique. Each question requires its own sort of approach. So if you find questions which don't look like mine, it's more about getting the experience and learning the approach. So this isn't the whole bunch of questions that you can see. This is just a selection. So this time, write the first 3 terms of 2x plus x squared, all divided by x, all raised to the power of 3 in ascending powers of x. So that looks a bit of a mess, and it does look quite difficult to do. So my calculator's ready to come in as well. So the first thing I'm going to do is I'm going to turn this into something I can work with, because the binomial theorem is a plus b to the m, and it's just 2 terms raised to the power of m with a plus sign between. So what I'm going to do is I'm going to divide each term by x. Now 2x divided by x is 2. And x squared divided by x is x. Like that. Sorry. Yeah, there we go. So actually this question is really, really nice to start with. So let's go. Ascending powers x. So the x powers to go up. So in that case, we need the x term second, which is what we've got. So the first term is going to be 2 cubed. Second term is going to be 3, choose 1. 2 squared multiplied by x. Now I feel like I can go faster here because we've done more difficult questions in this one in the past. 3 choose 2. 2 to the power of 1, which is 2, multiplied by x squared. And the last term then is going to be x, you don't need the bracket really, cubed. So it's a really, really nice little question. Just a gentle introduction into using algebra, or manipulating algebra before we start. So here we go. 2 cubed is 8. Next term, should be well rehearsed at this by now, is going to be 3 choose 1, multiplied by 2 squared, multiplied by 1 lot of x, which is 12x. The next term, here we go. 3 choose 2, multiplied by 2, multiplied by 1 squared, because there's an imaginary 1 in front of that x squared. In front of that x, sorry. Which comes out as 6, so that's 6x squared. Final term then, x cubed is just x cubed. So here we go. Here's the answer. I only wanted the first 3 terms, but because I saw it was a cubic, I thought, well, I'll just work the whole thing out. So I did more than what I needed to, but never mind. Here's your question. Pause the video and have a go now. Okay, so hopefully you've had a go at that question. And let's have a look at the answer. And there we go. So above that line there is the simplification. There it is. And we only wanted the first 3 powers of x in descending this time. So as we want descending powers of x, we've let the x be first, which is quite good because that's what came out of the simplification. That was my intention. And there we go. Hopefully you got it right. If you didn't, don't worry about it. Just correct it now and move forwards and just learn from your mistakes. Here comes another manipulated algebra question. So this time, write the first 3 terms of x cubed minus 2, all divided by x, raised to the power of 5 in descending powers of x. So I just need to be careful about that descending powers of x. First thing I need to do is simplify it. So I'm going to divide everything by x. So I end up with x squared minus 2 over x to the power of 5. So this one is a little bit of a step up. In fact, more of a significant step up because of that 2 over x there. But I'm not going to change what I do. As long as I've got my algebra skills with me, I know I can do this. Now, I only want the first 3 terms in descending powers of x. So this is hard to spot because we've got an x term there, x squared term there, and a 1 over x. Now, that is a 2, and that is x to the power of minus 1. And because that's on the left, and that's going to get raised to the power of 5, it's actually in the right order. That just comes down to experience. First term is going to be x squared raised to the power of 5. I'm only doing 3 terms. The next one, 5 choose 1, multiplied by x squared to the power of 4, multiplied by minus 2 over x. How lucky are we? The next one, 5 choose 3, x squared cubed, multiplied by 2 over x all squared. So there's another step up here with the algebra. So let's have a look. X squared raised to the power of 5 is x to the 10 because we multiply the powers. And the next one, what is going on my calculator for this one? Let's have a look. So this is the only place I think where a lot of students will get stuck. If you don't get stuck here, don't worry about it. Let's just have a review then. So 5 choose 1 is 5. Multiplied by 1 to the power of 4, and then remember there's an imaginary 1 in front of the x squared. And then this minus 2 is a numerator, so it's like minus 2 lots of 1 over x. So it's going to be minus 10. I'm going to have to move my calculator out of the way. Minus 10. That just comes from the coefficient. Let me bring it back up. It'll let me. There we go, it's back. So it's minus 10. Okay, I'm going to do this one in 2 stages. So I'm going to have x to the power of, should we get my pen back? X to the power of 8, and it's going to be divided by x because that's a denominator. So I'm going to end up with minus 10 x to the 7. So this is, you see, this is a bit of a step up now. Okay, the next term, I think my calculator is going to go over my writing here. Let me just make a mental note of minus 10 x to the minus 7 because I'm just going to rub that out. If you've got the space to write this out, you'll be doing really well. Okay, the next term, then let's get rid of the minus sign. Okay, right, so the next one, in my calculator, here we go, it's going to be 5 choose 2, which is 10. Multiplied by 1 cubed, so those two terms are quite nice. And then here, this minus 2 is a numerator. So it's minus 2 squared, and that tells me that lovely coefficient, which I'm just going to write underneath. That's my pen again, there we go. So it's going to be 40. And what about the power? So we're going to have x to the power of 6 over, now here, one of the rules of indices, if you square the top, you sort of square the bottom, the whole thing squared. So 5 over 2 squared is the same as 25 over 4. You square the top, square the bottom. Basically, it's where that 4 is coming from there. So you end up over x squared like that. And then you can just subtract the powers because you're dividing. Okay, so that is not an easy example by any stretch of the imagination, but it's where you need to be for this course. So my final answer, after all that, is going to be x to the power of 10 minus 10 x to the 7 plus 40 x to the power of 4 plus 3 dots because it continues. Okay, so make sure you've had a look at that example. Make sure you've got used to using the calculator to calculate some of these awkward coefficients. Here's your question. Pause the video and have a go now. Okay, so hopefully you can get caught out with me changing the word and putting ascending in there. So there we go. So in ascending powers of x, it's a bit sneaky, this one. I've tried to explain it as best as I can. So in ascending powers of x, I want the powers of x to go up. So this is where this one is a significant step up. Now you could write out the whole thing in the exam and then just rewrite it in ascending powers of x. You can do that, but they normally choose powers which are quite large, like 10, 12, 13, etc. So the first thing I've done is I've divided everything by x squared, which gets me to this line here. The next thing I need to sort out ascending and descending. So now this is x to the minus 1. So x to the minus 1. If I raise that to the 6, that's going to be x to the power of minus 6. And that just boils down to experience. So this is my most difficult example, probably the most difficult example you're going to see in all of these 5 videos. And it is very much an exam question. So if you didn't get that one, don't worry about it. Have a go now. So I've written over here in this bubble how this is ascending order. So minus 4, minus 3, minus 2. The numbers, the powers are going up there. So if you didn't get that one, just review it now, correct it, and have another go. So what I'd like to do now is pause the video, have a go at mini quiz 2, have a go at some of the questions, and come back and press play again. Okay, so that's all we was going to visit in this video. Let's have a look at our learning names. So I would have liked you to be able to calculate a binomial expansion where we had fractions included inside of the bracket, and to be able to manipulate algebraic expressions and then apply the binomial expansion. Thank you very much for watching. Best of luck with your studies, and bye for now.